do another topic, that is work done. First law of thermodynamics over. I am going to teach you work done in other process, in different process. Work done
Yes.
in different process. If we talk about the work done in different process, so first one we are going to study in adiabatic process. ADIABETIC, adiabatic process. First of all, we have to understand what is adiabatic process. Okay, the process in which, if we talk about this, the process in which there is no exchange of heat, no exchange of heat takes place, no exchange of heat takes place.
Takes place.
So if there is no exchange of heat takes place, means that is Q is equal to 0. Now what kind of this will be there? The container will be what they are saying. This container is the insulated container. Insulated container. It means these layers are, if you talk about this layer, okay. So on this layer, what is there? Insulation is there. If you talk about this layer, so this is the insulated layer. So insulated, if it is the insulated layer, means there is no possibilities of heat can go out or heat can go in. Getting my point?
Yes, sir.
So Q is equal to 0. So from first law of the thermodynamics, from first law of thermodynamics, if you can keep on writing little bit, not all the statement, little bit you can keep on writing, it will be better. Okay, in spite of uh, not writing, you can write little bit, whatever you find little bit important, that point you can please mention the notes, na, same time.
Yes, sir.
So from first law of thermodynamics, can you tell me what is the first law of thermodynamics?
Sir,
Hmm.
sir, it was sir, I forgot.
Mhm. Delta U is equal to
Okay, delta U equal to Q plus W.
Q plus W. Okay, thank you. So delta U is equal to Q plus W. Delta U, see, this is the work. Here is work done. Maybe on the system or by the system. Q is the heat supply the system or given out the system. This is change in internal energy. Change in internal energy. Now, if you talk about the same one, you apply this concept is apply because here W is there. So in adiabatic process, we are going to calculate work done. So Q is equal to 0, yes or no? This
Yes,
is.
sir.
So Q is equal to 0. So delta U is equal to what can be there? 0 plus W, yes or no?
Yes, sir.
So delta U is equal to, it will be that is W. Delta U is equal to W. This is our answers. This is our answer. Yes.
Yes, sir.
Okay. So little bit only, at least you write down this one, small thing. Because if I will not allow you to write, you
Yes,
may
sir.
not
I
get
will.
time. You may not get time and you will forget to write. So that is the problem.
Yes, sir.
In last class, I shared you the PDF. What is I
Yes,
wrote on
sir.
the screen. You got that?
Yeah, I wrote that, sir. Yeah.
Mail. I did share you mail, I think.
Yes, sir.
Hmm. Good.
Done, sir.
Okay. Next one we are doing. Okay. So work done in one process over. Next one, that is second one. Work done in isocoric process. Isocoric process. Okay. Here you please write down. Try to understand.
Yes, sir.
Isocoric means if you talk about isocoric means, है ना? Isocoric means, what do you mean by isocoric? Isocoric means the change in volume is constant. The change in volume is constant. Change
Constant.
in volume is constant. Okay.
Yes, sir.
Isocoric means the change in volume is constant. The change in volume is constant means delta V is equal to 0. Delta V is equal to 0. So
Yes,
what
sir.
we can write here, delta V is equal to 0 means change in volume is constant. So we know that is work is equal to force into displacement. Once place I told you, force into displacement. Okay. So force means
Yes,
what
sir.
I wrote, that is minus P external delta V. Yes, yeah, no.
Yes, sir.
So delta V is 0. From here we are putting the value. So W is equal to what? P external delta V is equal to 0. Okay. So W
Yes,
is equal
sir.
to what will be there? 0. Means if there is no displacement, suppose I am pressing on the wall, there is no displacement, means I didn't do any work. I just press it out. But no displacement means there is no work. Got it, the point?
Yes, sir.
Okay. Keep on writing, please. Done?
Yeah, done.
Okay. Now what we are going to do, we are going to do another process. We are going to take the another process. See, so in folder.
Yes, sir.
Wait. Yeah. So next one is work done in isobaric process. Work done in isobaric
Also,
process. Isobaric process. Now,
yes, sir.
if you keep in mind iso means same. Okay. Barik. Barik means pressure. Okay.
Yes.
So same pressure means at constant pressure. At constant pressure. Constant pressure. Constant pressure means what? Constant pressure cannot be 0. Keep in mind, pressure cannot be 0. Getting? If you are changing pressure 0 means it will be a vacuum. Getting? So some student what they do, that is pressure constant means the pressure is equal to 0. No, pressure is not 0. Change in no, that is pressure can be either 1 atm, 2 atm, 2.5 atm. It cannot be 0. If it is 0, it will be vacuum. So at constant pressure means that is constant atmospheric pressure. Constant atmospheric pressure, maybe atmos pheric, constant atmospheric pressure. This is what the point.
Yes.
Now what we can do, work done in isobaric process. So W is equal to, we are writing force into displacement, force into displacement, displacement, force into displacement. Displacement means what? If you are understanding, here is movable piston is there. Okay. So here is there. These are the gases are there. So what I am saying, if you are applying the force, pressure on it, so what will happen? The gas volume will be decreased up to here. It will go down. Okay. This is the pressure. So this is going, okay, here. So displacement means if you are going delta V is equal to, okay, delta V2 minus V1, V2 minus V1 you can write. So this is what the change in volume. Its compression is V2 minus V1. Okay. So that is what displacement. Force means pressure. So what is from the upside? You are writing the pressure. So P external, and that is you are pressure applying, so that is negative sign. P external delta V. W is equal to minus P external delta V. So the W will be always negative. P external delta V. This is what is delta V? Change in volume. This is going to be change in volume. And change in volume means what? That is going to be V2 minus V1. Okay. This is P external.
Yes, sir.
Okay. Can you please make a note of it?
Yes, sir.
Done?
No, sir.
Oh, okay, okay.
Done, sir.
Okay, okay. Now we are going next one. One question I am writing this one.
Yes,
Okay.
sir.
Question they are saying 2 liter N2 gas. They are saying 2 liter N2 gas at 0 degree Celsius and 5 atm pressure. Okay. Expanded
Yes.
again. They are saying expanded against constant external pressure. Expanded against constant external pressure.
External.
Constant against external pressure. Okay. Of 1 atm.
Yes, sir.
One atm. Okay. Until the pressure of gas reduced to 1 atm. Okay. So calculate, simple, you write down, calculate the work done. And calculate the work done. Now what we have to think about this, we have to try to solve this one. So here is constant external pressure is there. Okay. This is constant external pressure. So pressure is constant, means the process is isobaric process. Isobaric process. Yes or no?
Yes, sir.
So what is the formula of isobaric process? W is equal to, what is this? See, isobaric process, W is equal to minus P external delta V. Yes or no?
External delta V.
P external delta V.
Delta V.
So P external, if you are calculating P external, so it is one constant at 5 atm. It is there, that is 5 atm. No, 5, 2 liter of N2 gas at 5 atm pressure expended at a constant external pressure 1 atm. Calculate the work done. The sub question is a little bit mistake. 2 liter of N2 gas and 5 atm are expended isothermally against constant external pressure of 1 atm until the pressure of the gas reaches to what atm. The work. That's it. The problem is what they are saying. 1 atm. So 2 liter of gas at 0 degree Celsius and 5 atm pressure expended against constant external pressure of 1 atm. Calculate the work done. Okay, when gas reached to pressure, gas reached to pressure 1 atm. So it's tough question, tough. So they are saying that is 5 atm initially it is there. So pressure you are applied, that is 5 atm. This is they are saying 5 atm. You see 2 liter of N2 gas at 0 degrees Celsius and 5 atm pressure. Expanded, you are expanding this. Expanding means increasing the volume. Yes or no? This you are
Yes, sir.
expanding. So if you are expanding, the volume gets increases. And how much is there expanded? It means it is going to be what? 1 atm, up to 1 atm. This is there. So here what is happening here? So this can be the, here is the, when 5 atm is there, the volume is 2 liter. Yes or no? 2 liter of gas,
Yes,
0
sir.
degrees Celsius, 5 atm. So V1 is there, this is V1. So V2 we can calculate here. So that is what is the V1, V2 is equal to, V1, P1, sorry, V1, P1, yeah, P1, V1, you can write P1, V1 is equal to P2, V2. Have you heard this one? P1, V1 is
Yes,
equal to
sir.
P2, V2. So here what we are going to get V2, V2 is equal to, that is P1, V1 upon P2. So P1 is how much? 5, and here is 2, and P2 is how much? 1. So 5 to the 10 liter. Yes or no? Yes.
Yes, sir.
Okay. So P external, they are saying, if you are talking about P external, so what we will be able to write, that is 1 atm. Okay. Because constant external pressure of 1 atm there. Then they are saying, because the process become isobaric process, I told you. Now, what they are saying, delta V. Delta V is B means V2 minus V1. So here is minus 1. V2 value is how much? 10. We calculated here 10. And minus is 2. So how much is going to come? That is minus 8 liter. Okay, liter and ATM. And 1 liter ATM is equal to how much, Jana? 1 liter ATM is equal to how much? Can you tell me? 1 liter ATM is equal to how much? 101.3. It is joule. So if you are calculating in
Yes,
joule,
sir.
so that is minus 8 into 101.3 joule. So it is going to give, it is minus 810.4 joule. This is our required answer. Yes or no?
Yes, sir.
Okay, can you please write down? Done.
No, sir.
Write down, little fast. Today you share one chapter.
Okay.
Today you share that one, organic chemistry. Okay, whatever the
Okay,
topic
sir.
not taught, definitely I will complete. Okay. So
Yes,
now,
sir.
now what we are going to do, we are going for the changing the process. So up to this one. Now work done in vacuum we are going. Work done in vacuum. So if you talk about work done in vacuum, so what you are going to find? Vacuum means no pressure. Vacuum means no pressure. Yes or no?
Yes, sir.
So P external should be there, it should be 0. Pressure should be 0. So,
0.
so work done, how to calculate? So work done. So work done, how we calculate? Work done is equal to what the formula is, apply P external delta V. Yes or no? So W is equal to P external, there is 0. Delta, then delta V. So if P is 0, so delta V into 0 means it is going to be 0 now. Yes,
Yes, sir.
so we can write, so work done in vacuum. Work done in vacuum. Where? In vacuum. So work done in vacuum should be 0. Vacuum is 0. Work done in vacuum is 0. This is the concept. Can you please make a note of it? Done?
No, sir.
Okay. Are you writing, Janab? Are you writing?
Yes, sir.
Okay.
Done, sir.
Okay, thank you. Now, the last one we are going to do. Last one, let us try to understand last one.
Yes, sir.
Okay. So if you are talking about the last one, they are saying work done in isothermal reversible process. Isothermal reversible process. Now we need to understand this meaning of isothermal. If you are talking about isothermal, so iso means theme, thermal means temperature. So constant temperature, it should be, that is what? Constant temperature. It is the constant temperature. Reversible, they are saying reversible. Reversible means very slow process. It is going to be very slow process. This is very slow process. Very slow process. This is what is known as reversible process. Okay. So means that can be reversed. That can be reversed. The work can be reversed. This is what is known as reversible process. Okay. So how the work is given? So W reversible. Okay. So W reversible is minus 2.303 nRT log V2 upon V1. This is what the concept. Direct formula is there, no derivation. Directly you need to do the calculation based on it. So W reversible means minus 2.303 nRT log V2 upon V1. This is what the concept. Getting my point?
Yes, sir.
Now you see, we know that is P1, P1 B1 is equal to P2 V2. Yes, no. So if you are
Yes, sir.
putting V2, V1 sending that side. So here is V2 upon V1, and this side what will come? P1 upon P2. Okay. So at the place
Yes,
of
sir.
V2 upon V1, we can place it out this one also now. So W reversible, if you are calculating, is equal to minus 2.303 nRT log. It is going to be P1 upon, what is going to be? P1 upon P2. This is the W reversible. Getting my point? This is Jana. Are you be able to understand this?
Yes, sir.
Okay, let's try to solve some problem based on it. So the can you write the definition, please? Can I write the formula, please? Can you write the formula?
Yes, sir.
Done?
Hmm. No,
Can,
sir. Wait.
okay, good, good, good. Can I erase now?
Wait. Yeah. Now you can.
Okay. Now, when you talk about the next point, the question is there. On the basis of this, let us try to solve the question often asked on the basis of this. They are saying calculate, here the question is there, calculate the work done. They are saying calculate the work done during, calculate the work done during isothermal. It is what? Isothermal reversible expansion. Isothermal reversible expansion of 1 mole of N ideal gas, 1 mole of ideal gas from 10 atm to 1 atm at 300 Kelvin. Okay, so this is what the question they are asking. R value they are saying that is 2 calories. Okay, R value is 2 calories. CALORIES. R is 2 calories. So A number option they are saying minus 1381.8 calorie. CAL means calorie. So here I am writing that is CAL. Option number B is that is 2318.5 calorie. Option number C is 1519 calorie. Option number D, none of these. None of these. This is what the answers. Now, let's try to understand this one. How can you be able to understand? Calculate the work done during isothermal reversible expansion of 1 mole of an ideal gas. So what are given here? Firstly, let us write. N is equal to, they are saying 1 mole. R value they have given that is 2 calorie. In calorie, R value is 2. T value they have given 300 Kelvin. Okay. Then they are saying that is 10 atm to 1 atm. What they are saying? 10 atm. So P1 is 10 and P2 is equal to 1. Okay. So work done here, I am writing work done in isothermal. See, the temperature is constant means isothermal reversible process. REV, reversible process. So what we can write reversible process? W reversible is equal to minus 2.303 nRT log. It is going to be P1 upon P2. You can see in the term of volume it is V2 upon V1, but in the term of pressure P1 upon P2. I explained you this way, this concept. Yes, now can you be able to understand this?
Yes, sir.
Okay. So minus 2.303, it is N value is 1, R value is 2, temperature is 300, log P2 upon P1. So P2, where is the P2? P2 is, you can see, here P2 is 1. Oh, no. P1 is 10, P2 is 1. Yes, no?
Yes, sir.
Because their pressure, you see what they are saying. Calculate the work done during isothermal reversible expansion of 1 mole of ideal gas from 10 atm. So it is P1 to 1 atm. So that is correct. Can you tell me the log 10 value, Jana? Log 10, can you please tell me?
So I locked in 1.
Okay, thank you. So W reversible, if you are calculating minus 2.303 into 1 into 2 into 300 into 10, log 10 value 1. Solve it. So it is coming minus 2.303 into 600. Okay. So how much will come? 6 3 ja 8. 6 3 ja 8. 6 0 ja
Yes, sir.
0. 6 3 ja 8. 6 2 ja 12. Okay, point after how many digits we have to put? That is double zero is also there. So 3 digit 1 2 3. This is point. So it is 6 3 ja 12. 6 no wrong. All wrong
No,
one.
sir. It's wrong one.
6 3 ja 18. I am what
Yes.
6 3 ja 8 I am writing. See double zero I place this double zero. Then I am writing this one. 6 is 18. 18 is 8 carry 1. 6 0 0 and 1. 6 is 18, that is 8 carry 1. 6 2 is 12, 1 13. This is minus. Decimal after 3 digits. So 1 2 3. So it is coming, how much is coming? Minus 1381.8 calorie. Can you understand this one?
Yes, sir.
Okay, so this is what the problem. Please write now little bit.
Yes, sir. Writing. Yeah, done, sir.
Okay, thank you. Okay, so let's try to write one more problem. Okay, so what is the problem? Question is here. Yeah, at 27 degrees Celsius, 1 mole of an ideal gas is compressed isothermally and reversibly from a pressure of 2 atm to 1 atm, 2 atm to 10 atm, sorry, 2 atm to 10 atm. Calculate, okay, delta U and delta Q. They are asking so many things. Delta U and Q for the process. Okay. Okay, so see this is the process is quite tough. Isothermal, they are saying, and reversible. Isothermal and reversible. So isothermal means note. It is
Yes,
a
sir.
note. Isothermal means iso means same, thermal means temperature. Isothermal means temperature constant. Isothermal means temperature constant.
Yes, sir.
Temperature constant. Temperature constant. That is temperature constant. That is what we can write. The isothermal means temperature constant. That is also internal energy is constant. That is also change in yeah, change in internal energy is also constant. It means delta U is equal to 0. So from first law of the, so from first law of thermodynamics, first law of thermodynamics. So see thermodynamics. I will leave you only this period, only this question only. Thermodynamics. Delta U is equal to Q plus W. So delta U is equal to 0, Q plus W. Yeah, you can write W is equal to what can you write here? You see what you can write. You can write W plus Q is equal to 0. Yeah, W is equal to minus Q. Yes, yeah, no.
Yes, sir.
So minus W formula is there. What is there? Minus 2.303 nRT log. What is their pressure they have given or volume? You see in the questions, 1 mole of ideal gas compressed isothermally from a pressure. So that is P1 upon P2. So you can place it out the value minus, it is going to be 2.303. Okay. And here will be, we are calculating the 2.303. N value is how many mole they are talking about? 1 mole. R value we have to write, that is 2 calorie. R value is 2 calorie. Temperature they are talking about 27 degree. So 27 degree means in the Kelvin, 27 plus 273 means 300 Kelvin. So temperature is, it is going to be 300 into log P1. P1 what is there? P1 means it is going to be, they are saying, so if you talk about P1, how much is there here? Say 1 mole of ideal gas is compressed isothermally reversibly from a pressure up 2 atm to 10 atm. So P1 is, they are talking about 2 and that is 10. Okay, 2 atm to 10 atm. Now when you talk, here we are calculating this one, you can write little bit different way. So W is equal to minus Q, it is later. So firstly W we are calculating. So here if you solve, this is log value is there na. So 1 by 5 will come. So 1 minus log 5. So how much log value you see? Minus 2.303 into 2 into 300 into log 1 by 5. Okay, log 1 by 5. So you can write down this here. So here is W is equal to minus 2.303 into 600 into log 1 by 5 means log 1 minus log 5. Okay, so here is log 1 value is 0. Keep in mind, log 1, if you are talking about log 1 is equal to 0. So minus 2.303 into 600, log 1 is what? 0 minus log 5. Okay, so see here what can be log 5 value. 6 point something is there. Wait, let me check a little bit. 1 second. Log 5.
Yes, sir.
Log 5. So let's take it. 69. I know 0.6989. Okay, this is log value. If you solve it out, the value is going to be how much is coming. This value is going to come. That is, it is coming. If you multiply this one, this all minus is positive will come. It is coming how much? Plus 956.84 calorie. This is coming. So this is W. Up W is equal to what is there? Minus Q. Here you see from this equation. Here is what is there? W is equal to minus Q. So Q is equal to minus W. So here is Q is equal to W value. If you are writing that is, it will come minus W value 956.84 calorie. This is.
Yes, sir.
This is our required answer. So Q value we got. And what delta U is, already I told you, delta U will be 0. Why delta U is 0? Because temperature is constant. So delta U is equal to automatically 0. So this is all about the problem based on the reversible process. isothermal reversible expansion of gas. There are so many other problems are there, which I will share you on the PDF form. Okay. So will you solve one more
Okay,
problem?
sure, sir.
Can I give you one more problem or what?
No, sir, enough. You share me on the PDF.
Okay. Mhm. Okay. Bye. Can you please write down this one at least, please.
Yeah, sir, I'm writing down.
Mhm. I'm taking the pic and immediately I'll send you back. And what time you will share that one organic chemistry one notes? You are saying that one college.
Sir, I'll share you by 10. 10 or
10,
11.
okay. 10, 11 or morning. Again, I will remind you once. You can share
Yes, sir.
anytime. Okay. But don't forget to share.
Okay, sure, sir.
Done?
Yeah, sir, done.
Okay. You can leave the meeting. And I'll say I'm taking the pic now. I'll share it. Okay.
Okay.
Mhm.
Thank you so much, sir.
Okay.
Thank you.